Hello everyone. I'm going to give a very brief review on the physics portion for your exam. This part today, we're going to cover two items. One is a review of trigonometry in right triangle, and the other one is we examine the movement on plane. In this case, a very simple one, on the surface. Okay. So to review, for you, that let's say that I have a right triangle. Okay, so right triangle means that the triangle that has one right angle here. So in this case, I put it over here, right? So let's say that I have a right triangle ABC. Now the trigonometry part uh, will have you will have to identify the other angles. Okay, so right now in this triangle ABC, right, you have angle B is 90 degrees, right? And then you have to identify the other two angles. So we have other angles, angle A and angle C. All right, so let's say that I have the measurement of angle A is I call it alpha. So alpha is, like a degree. Okay, a number could be like 25 degree, could be 30 degree, something like that. And then so here I have this angle A here. So this is alpha. All right. Now, one thing that doesn't change in this right triangle is that the hypotenuse doesn't change, right? Hypotenuse is the side that is opposite to the 90-degree angle. Okay, so hypotenuse doesn't change. Hypotenuse doesn't change and is opposite the 90-degree angles. It also meaning that that it is the longest side in the triangle. Okay, so in this case, AC is the hypotenuse of this triangle, right triangle ABC. All right, now there are two other items that I want to introduce you to. One is the opposite side, and the other one is adjacent side. So when we talk about opposite, you have to think about the location, right? And a reference. So opposite to what? Or opposite of what, right? And adjacent to what? Remember that, right? So opposite, we have to, well, the opposite is a abbreviation, but opposite of, say, alpha, right? So opposite of alpha is what? If we have an angle alpha here, so where's the opposite? Opposite this, right, is BC. Okay, and adjacent to what? Adjacent to alpha. Again, so here alpha adjacent is this AB. So I have AB. All right, very important to identify these three items first. Okay, hypotenuse never changes, right? Hypotenuse is always the longest side in a right triangle. It's opposite to 90 degrees. So when you identify the 90-degree angle, right? When you identify the 90-degree angle, you identify the hypotenuse, right? And then when you talk about opposite, you have to think about opposite of what, right? Opposite of what angle? So opposite of alpha here, so that's BC, and adjacent to alpha is AB. All right, so then we can find out, sine and cosine and tangent. Okay, so here we have psi of alpha again. Psi, we have to identify the psi of what angle. So in this case, psi alpha. So that would be opposite of alpha divided by hypotenuse. Okay, so opposite of alpha, so that would be BC here, right? BC, and divide by hypotenuse. Hypotenuse here is AC, so divide by AC. All right. Now cosine of alpha. Cosine of alpha is adjacent to alpha divided by hypotenuse, and adjacent alpha would be AB, and hypotenuse is AC. All right, so that one. Okay, and then we have, let's say we have tangent. Okay, so tangent. Now tangent of alpha, again, sine, cosine, tangent, cotangent, you always have to identify the angle associated with it. So tangent of alpha is actually equals to what? Opposite divided by adjacent. So opposite of alpha divided by adjacent of alpha. So in this case, we have opposite of alpha is BC divided by adjacent of alpha is AB, right? Okay. Now think about this. So sine of alpha is this, and cosine of alpha is this. Actually, if you do the calculation, you will see that tangent of alpha actually equal to sine of alpha divided by cosine of alpha as well. Okay, and then you can do the calculation to prove it just by take this divided by this. Okay, and then you should see that like it equals to BC over AB. Okay, so now let's do another. So let's see that we going to do. We have another angle here, right? So let's say that we have an angle C here, and I'll call it angle beta. Okay, angle beta here. All right. Now I want you to find the sine, cosine, and tangent of beta. And so please pause the video and then work it out in your notebook. Okay, so for this one we have the hypotenuse is AC, never change, right? And so for the beta here, right, we have the angle beta here. So the opposite of beta is actually this side here, AB, and adjacent to beta would be BC. All right, so you just have to follow the formula. So sine would be what? Opposite of beta, which is AB, divided by hypotenuse, so they could divided by AC. So cosine beta would be equals to what? Adjacent to beta would be BC divided by hypotenuse AC, and then the tangent of beta would be the opposite divided by adjacent. So opposite of beta would be AB divided by adjacent to beta would be BC. Okay. All right. So let's do some other some more practice. Okay. So in this case, I want you to find out for me sine, cosine, tangent of alpha and beta for these two right triangle. So again, please pause this videos and then do it in your notebook and then check the answer later. Okay, everyone. So this is I hope that you all get the right answer as shown here. So please pause this video to review the answer, and if you made any mistake, come back to the previous explanations and walk it through on your own. All right. So let's move to the next part, which is the movement of the objects on simple plane. So in this case, on the surface, right? So let's say that we have a block, 5 kilogram box, and at rest. Okay, so what does it tell you? At rest, meaning that like acceleration would be equal to 0. So that's when you annotate a problem. This is something that you need to know. And then what we have to draw a free body diagram for this for this problem. Okay, so what's going on, what are the forces that are acting upon this block. We have the weight, which is mg, okay, and then we have the normal force that is opposite, like it's like perpendicular to the surface. Okay, now is that all? As actually there is the friction force, right? It's actually a friction force that is at rest. Okay, so we have friction, but in this case this is a static friction because the object is at rest. So let's just say that just pretend that just assume that the movement of the object is in this direction. Let's just say that, all right, but then the acceleration equal to 0. Now, but let's say that if the object is moving, then it will move to the right. Then the static friction would be going opposite of that direction. So this is normal force and this is friction force. Okay, so Newton's second law say what? So Newton's second law saying that the sum of the forces, which is F net, right, equals to ma. Okay, so that's the second Newton's second law. And then F net here would we have that equal to what? Mg plus normal force plus F friction, in this case static friction, equal to ma, and remember the a equal to 0 here, so that would be equal to 0. All right. Now, next, we're going to analyze this equation on the OX and OY. Okay, and this is where it's interesting because you need to identify, your positive, so reference frame. So here, let's say that I have OX here and OY here. Okay, so OX, and this is up to you, right? So you completely have the freedom on it. But in this case, I put the positive side is the movement on the right. Okay, and OY here is going up, so going up is positive. Okay, so on OX, let's say on OX, right? So MG, now MG is actually what? MG is going straight down like this, right? So it's actually perpendicular to OX, right? So that would be equal to 0 because MG here perpendicular to OX. All right. What about normal force? The normal force, look at this. Normal force is going up, right? And going up parallel to the OY, right? So that would be equal to itself. So that would be plus N, right? Positive N. And then let's take a look at the force of friction. Now friction is going, we're talking about OX here, right? Oh, hold on. So I make a mistake here. So N is actually going up, right? But then we're talking about OX here, right? So N is actually perpendicular to OX, right? So this will be equal to 0 too. Sorry about that. Because N here positive, perpendicular to OX, right? Equal to 0. And what about F friction? So friction here is actually parallel to OX, right? But then it's going to the left. Now remember that here we assume that we put that like as our reference that OX is actually positive, going to the right is positive, but F friction is going to the left, right? So that means it's going, so that means it has to be minus F friction equal to 0. All right, so that means F friction here equal to 0, and that makes sense. Okay, that makes total sense. All right, now we do on OY and OY. So let's do on OY. On OY, so I have what? I have this mg going down here, going against this OY here, so that would be minus mg plus n, and friction is actually perpendicular to OY, so plus 0 equal to 0. So here n would be equal to mg.